We have another terrific show for you today and an amazing guest. Welcome to the Tech and Space Leader Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I am really excited to introduce our guest for today, Alex Deitch. He is the CEO and founder of Propel Space. Welcome to the show, Alex.
Thanks for having me, Lisa.
Absolutely. It's so great to have you here. Maybe you can start by giving us just a little bit of background on yourself and Propel Space.
Yeah, absolutely. I have been in the space industry for about 15 years now. I have worked big companies and small companies across a range of different types of technology. I've worked CubeSats and microsats. I've worked Mars missions for mechanisms, working on Perseverance right now. And then most recently started Propel Space, trying to fill the gap for the supply chain for pointing mechanisms that doesn't really exist here for the small sat industry. Everything exists for the large ones, so trying to fill that gap for the small ones.
Wow, what an amazing background. And so maybe you can go into a little bit more detail. What is the missing piece? Why don't these pointing mechanisms exist for small sats?
The There's a few reasons, but mostly a lot of the systems were designed for large, elegant spacecraft. So a lot of the GeoBirds have a lot of these kinds of technologies. Scaling those same systems down to the same cost point or the same size needed for the small sat industry has been a slow process, or a lot of spacecraft just choose not to use them. What's happening now is a lot of the companies within the small sat industry, whether they're telecom, Earth observation, servicing, they're realizing they need more flexibility. They can't just be a refrigerator box that has to point around and rotate. They need some sort of capability to look over here and then point over there. And so those pieces are missing for their own revenue streams and their own bottom lines. And we're trying to create a robust supply chain to meet those needs, regardless of the mission.
How hard is it to meet the, I guess, size, weight, power type of constraints that you have on a small satellite that you may not have on a larger satellite?
It's it depends on how you approach it. One of the things that we did here at Propel Space was we did not take the standard approaches of how people did mechanisms for the large spacecraft previously. We didn't take the heritage designs. We actually started from the ground up to make optimized, miniaturized systems for the actual field and size of spacecraft that we were partnering with. And so, um, first principles engineering, trying to just start from scratch. You don't have to base things off of heritage, so you have the freedom to kind of start in a more optimal manner. And by doing so, we've been able to select and design systems far smaller than what previously existed.
Oh, that's great. So right now, small sats that are already up there flying, they don't have these mechanisms. They literally need to rotate the entire small sat in order to, I guess, point toward different things.
Exactly. For one example is, imagine you're in your car and you're driving, but your tires are misaligned, and so you're always drifting to the left. Well, you're always having to force the car to be straight. That's kind of like how spacecraft with thrusters currently operate. If they're not exactly aligned with the CG of the spacecraft, they're always kind of like pushing to the side. And so the reaction wheels are trying to push it back to the right way, which stresses the overall system. Another example is with Earth observation satellites. They may be looking over here and they're trying to track information. It might be wildfires, it might be looking and tracking ships, what have you. But the ground station where they need to talk to and actually communicate that information is over there. And so they'll stop looking here, they'll rotate their spacecraft to then communicate there, and then they'll have to rotate back in order to go back to what they're observing. And so the dexterity to not be able to do two things at once limits a lot of these capabilities.
Yeah, indeed, indeed. And how's that affect the propellant and fueling of these satellites? I mean, obviously, it seems like you'd be using a lot more fuel to point one direction, then point another, and then go back to maybe your mission target.
There's a lot of propellant usage and it's always been this way within the small sat industry, but everybody's looking for more efficient ways to do things. And so being able to adjust as you use propellants, your CG within your spacecraft shifts. And so being able to always point and track where your CG is just means you're that much more efficient. It may
Yeah.
not mean that you are doing something crazy or astronomical with maneuvering, but maybe you get an extra month out of your spacecraft. Maybe you get an extra 3 months out of your spacecraft. Maybe you can downsize your reaction wheels because they're not always having to fight this torque within your spacecraft because you can always adjust how you're using your thrusters. So it's a system of systems problem. And once you address it from that fashion, you can be far more efficient in how you operate your spacecraft and far more efficient in how you build your spacecraft.
Got it. Where are you in the development process right now?
So we currently are finishing up qualification on our two-axis gimbals for EP thrusters, as well as our hold down release mechanisms. We ended up having to design our own HDRMs or hold down release mechanisms in order to hold our gimbal. And that also turned into its own product just from a size and simplicity standpoint. It's very miniaturized, but very capable. So it was a nice finding when it came to that. But those are going through qualification, and then we are flying a few gimbals and then a few dozen HDRMs in Q2 of next year.
Wow, that is really exciting. So that's going to be your first space flight then.
Correct. Yeah, that'll be the
Excellent.
first. That'll be the first push. But we already have a number of additional customers for the hold down release mechanisms. And then there's a lot of interest on some other pointing capabilities with regards to our architecture for the gimbal. So right now we're doing EP thrusters, electric propulsion thrusters. But the same guts that move those things, we're actually adapting those to antenna pointing, optics pointing, and we're getting some pretty solid interest that we'll be able to announce January next year.
Wow, fantastic. Well, we'll have to have you back on the show then. But for now, can you talk a little bit about some of the customers or missions that you will be able to support?
Absolutely. So the interesting part is when it comes to efficiency and miniaturization, there isn't really a mission that wouldn't benefit, but the majority of them have to do with Earth observation. They may want to maintain a certain what's called an LTAN, so a time within a certain orbit. In order to do that and fight against the solar pressures that are pushing it out of the way, they need a specific gimbal to help realign and thrust it back to the right spot. Another area of interest are servicing vehicles. So spacecraft that are wanting to go up, observe another object or dock with it, move it to a different orbit. You can imagine if this is spacecraft one and this is spacecraft two, and then they join together, your CG between one and two now completely changes. And so you need to repoint where your thrust is going through the combined spacecraft stack. And so we're getting a lot of interest in those areas as well because they need that dexterity and that flexibility to open the new evolution of the servicing industry.
Right, right. Can you talk a little bit about volume efficiency and why it's so important for modern spacecraft?
It's the conversation has always been around mass, and it started out that way, especially when 20 years ago, when it would cost an absolute fortune to get any small spacecraft up. Nowadays, with cost being so low for mass, the challenge is how much stuff you can stuff in the same volume or footprint on a launch vehicle. And so any time that you can take a certain component or mechanism and make it half as tall or a quarter as tall, that gives you more room internal to a spacecraft to either expand a tank, and maybe you can increase the amount of life that you have because this gimbal with your thruster isn't filling so much volume that it's restricting some other area of your spacecraft. So it's doing more with the same volume that you're allocated on the launch vehicles.
Great, great, fantastic. As I understand it, Propel's really using kind of a standardized approach and plug and play. Can you talk a little bit more about that?
Yeah, yeah, absolutely. So we a number of different mechanisms throughout the past have been you buy this pointing thing, but then you have to go and figure out the electronics, and then also you have to figure out how to hold it down. It was a lot of piecemeal in trying to figure out how to make this one thing that was then levied on the customer itself. Our approach is any of our systems are as standardized. I'll use that word, but basically we try to make them as simple as possible. So our hold down release mechanisms have smart electronics so that we can actually monitor and provide the right amount of current in a very small package with a small amount of power. On the gimbal systems, we hold the actual gimbal during launch, during vibration, with those same HRMs. So those are always included. And then the drive electronics actually sit underneath the body. So you buy the entire package that's ready to go, plug in, attached to a thruster. You don't have to worry about adding any additional components or doing any of your own non-recurring engineering in order to make this thing happen. We also pursue this with our partnerships. So we work with a number of different thruster providers so that we can provide them the gimbal, and then they can fully integrate the gimbal with their propulsion system so that the final customer doesn't have to do any additional work in order to attach anything. Everything's just built to print, ready to go. You just attach it on the spacecraft. There's very little additional engineering needs from their side.
Yeah, wow, amazing. What do you see as the biggest challenges that spacecraft manufacturers are really facing today?
Supply chain is definitely a big one. There's there's only so many companies out there who can do any specific thing, and this isn't unique to mechanisms. Mechanisms is one just because there are fewer mechanism engineers, and there were fewer companies that make these kinds of things because they were. And as a mechanisms engineer, I would always say, like, if you can avoid a mechanism, do so. But these days, in order to push revenue streams, you need to start getting more flexible. Um, but when it comes to the resources out there, there are only so many companies to go around. There are only so many engineers to go around. Vertically integrating every aspect of a spacecraft, especially for smaller companies, is extremely difficult. You can't find enough people in a shorter amount of time in order to hit the schedules that you need in order to launch your spacecraft. So a lot of it has to do with just truly finding supply chain and solutions that can meet your needs in the schedules that you have and in the cost restrictions that you have in order to get your own spacecraft and your own startups off the ground.
Right, right. So how does Propel kind of address that as far as lead times and costs?
So we took the from the ground up approach with that as the main focus. So all of our components are, and this is very specific, but all of our components on like the metal for our 2-axis gimbals, they're all 3-axis machining, and that's it. There's no 4-axis or 5-axis or complicated systems. We've designed the structures so that they can all be low cost materials and very rapidly easy to machine systems. The components that we choose and the way that we purchase our components, we buy the long lead items in bulk so that we always have those on the shelf. That way we're ready to assemble and make hardware in 2 months rather than in 18 months. Um, and then even with the electronics components, everything that we choose is off the shelf, short lead time. We try to start that as kind of the motto is we want to fill the supply chain gap. And if we're going to do that, we have to be mass manufacturable.
Yeah, yeah, that makes sense. In terms of reliability and just, I guess, your overall design philosophy, how do you actually test before you fly?
So we test quite a lot. On our two axis gimbals, we've actually gone through 14 iterations in the past 18 months. Um, Different improvements, different ideas, different roadblocks, and finding ways not to do things. We go with speed and iteration, and then we build upon our lessons learned. As of right now, we just finished up some vibration testing ahead of qualification testing, just to validate and make sure that everything that we thought was going to happen through the different analysis and designs was going to do so. But an ultimate thing I'd say is that from the ground up on the design, we chose to be simple. We tried to eliminate as many complex components as possible. A lot of them are based off of heritage ideas and heritage approaches. So if we can eliminate those things and really just look at it like, what do I need? The minimal amount of hardware in order to get the job done. By keeping it simple, it allows us to actually have a more reliable system with less testing rather than needing to add a lot of complexity for a lot of features that aren't required for the final operation of the mission.
Great, great. How do you see the growth of the small sat market? I mean, obviously, lots of launches, lots of new satellites going up pretty much every week. How is this, I guess, impacting the innovation from a spacecraft mechanism perspective?
I find it really interesting and fascinating. There are always new startups, new ideas. The reentry market is booming. Tons of different companies popping up around that. A lot of areas within manufacturing for pharmaceuticals. The whole idea of servicing has been around for a while, but it's kind of getting its feet under itself and moving forward with new demonstrations and new systems. Um, it's very, very exciting to see all these different spacecraft and all these capabilities coming to fruition. A lot of these have been great ideas for a while, but now people are truly launching them, getting business models figured out, actually bringing in revenue. So it's an exciting time, and realistically, it is probably only going to accelerate. The more that others prove out certain niche markets that they can do in space, once they prove those out, others will come in and start doing further and greater things. And then once you get beyond the typical low Earth orbit areas, now we're expanding into geo. Now we're going into cislunar. The economy and the industry is just going to continue to expand in those areas. And so we're excited to be a part of it and support the increase in flexibility for a lot of these spacecraft and customers.
Absolutely. Well, fantastic. Thank you so much for making time to be here today. What should someone do if they're interested in learning more about Propel Space?
If you're wanting to learn more, you can definitely go to propelspace.com. We've got granted, it's a fairly limited website, but you can definitely go there. You can always email me at info@propelspace.com as well. Happy to have conversations around mechanisms, different ideas, different collaborations, and just talk about the next steps within the industry.
Excellent. Thank you again for being here today, Alex. We really appreciate it. It was a fascinating conversation.
I appreciate the time. Thank you, Lisa.
Absolutely. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leader Show.